Now we have drawn the aggregate expenditure function. Aggregate expenditure function is a function of income, and it looks like this. Okay, so when your income is this, total expenditure is this. When the economy has this income, the planned expenditure is this. When the economy has a higher income, the economy plans to spend more. Now, remember in chapter 4, we says income should equal to expenditure, which should be equal to total production. Total production equals total income equals total expenditure. Everything that is produced will be purchased by somebody who spend money. The money is from his working, from his income. So when you sum up income, it should be equal to the sum of the expenditure in the whole economy, which should be equal to the total value of the production. So in equilibrium, expenditure is equal to income. Expenditure is equal to income. Therefore, aggregate expenditure is equal to income. Variable on the y-axis is equal to variable on the x-axis. So, is there a point on the planned aggregate expenditure function where actually income is equal to the planned expenditure? The answer is yes. How can we find it? The answer is to draw a 45-degree line. Because any point on the 45-degree line, x equal to y, AE equal to y, AE equal to y, and this point, income equal to expenditure, and this point happens to be on the aggregate expenditure function. Therefore, this point is the planned aggregate expenditure when income is equal to expenditure. We call this point equilibrium expenditure, equilibrium income. That's from this graph. In our example, when income equal to expenditure, income equal to expenditure, it's somewhere close to D. See? Now, what happens if there is an increase in autonomous expenditure? Say, for example, increase in autonomous consumption, or increase in investment, increase in G, increase in X. Remember, what is autonomous expenditure? What is autonomous expenditure? Autonomous expenditure is the y-intercept of the aggregate expenditure function, right? So an increase in autonomous expenditure, the only thing changed is the y-intercept. The slope doesn't change. Therefore, aggregate expenditure function shifts up. Now, on this graph, autonomous expenditure shift up by 0.5. Autonomous expenditure shift up by 0.5. Then what happened? Originally, this is the 45-degree line. Originally, the equilibrium is right here. That is, the equilibrium expenditure is 13. Where is the new equilibrium? Where is the new equilibrium? The new equilibrium is right here, 45-degree line cross aggregate expenditure function. So the new equilibrium is 15. Did you see that? When I increases autonomous expenditure by 0.5, my income increases, my equilibrium expenditure increases by 2. This is a very important concept in macroeconomics that is called multiplier effect. What is the multiplier effect? Now, look at this. Aggregate expenditure is equal to C plus I plus G plus X minus M. If you increase the autonomous expenditure, where is the autonomous expenditure? Autonomous expenditure is autonomous consumption plus I plus G plus X minus autonomous investment, right? This is the autonomous expenditure. And then plus induced expenditure. My right hand side increases by 0.5. The left hand side should also increases by 0.5, right? But no. My equilibrium total expenditure increases by 2, which is more than 0.5. This amplified change in real GDP, equilibrium income, equilibrium expenditure, that follows an increase in autonomous expenditure is called the multiplier effect. The multiplier effect. Let me explain the multiplier effect. Here is the basic idea of multiplier effect. Let me write down this again. Aggregate expenditure function is C plus I plus G plus X minus M, right? C depends on income. Consumption depends on income. So C is autonomous consumption plus marginal propensity to consume times income. I is assumed to be autonomous. G is assumed to be autonomous. X is assumed to be autonomous. M depends on income. So if you put all the autonomous part together, and put the induced part together, so this is the autonomous expenditure. This is induced expenditure. Now, in equilibrium, income is equal to expenditure. Therefore, if you look at the equation here, income equal to expenditure. When autonomous expenditure, the first part on the right hand side, increases by this much, then left hand side should increase by this much as well, right? So that this equal sign can hold. However, when income increases, what happened? Remember, we have income here. When income increases, induced expenditure increases. So the second part of the equation on the right hand side increases further. Then the right hand side increases, the left hand side will also increase. But when income increases again, the induced expenditure increases again. And when the second part of the right hand side increases again, the left hand side increases again. So this part keep increasing because y keep increasing, this part keep increasing. That is why the total increase in equilibrium income, equilibrium expenditure is much bigger than the initial increase in autonomous expenditure. That is why when autonomous expenditure increases by this much, 0.5, shift up by 0.5, the equilibrium expenditure, equilibrium income increases by 2, more than 0.5. This is called the multiplier effect. Let me say it again. When any component of the autonomous expenditure increases, equilibrium aggregate expenditure increases, income increases. But when income increases, induced expenditure increases. When induced expenditure increases, because induced expenditure is part of the aggregate expenditure, therefore aggregate expenditure and income increases again. So keep going and going and going. Income increases by more than the initial increase in autonomous expenditure. This is called the multiplier effect. So the equilibrium expenditure increases much more than the initial increase in autonomous expenditure. How much? This is called the expenditure multiplier. The expenditure multiplier is the amount by which a change in autonomous expenditure is magnified or multiplied to determine the change in equilibrium expenditure and real GDP. So let me give you an example. If you put 5 mushrooms into a lab and you don't do anything, the day after you come back to the lab and you find 15 mushrooms. So these 5 mushrooms just multiply by themselves. At the end you get 15. Then how big is the multiplier? The answer is 3. Because it multiplies itself 3 times to get 15. So the initial increase, you put 5 mushrooms into the lab. At the end, you get 15 mushrooms back. Therefore, the multiplier is 3. Easy enough? Therefore, the size of the multiplier is, originally you increase autonomous expenditure by how much? And then at the end, the equilibrium expenditure increases by this much. Then this will be the multiplier. And I'm going to prove that the multiplier is actually 1 over 1 minus the slope of aggregate expenditure function. I want to prove here, and if you think it's too complicated, that's fine. I just want to prove that what I'm saying here is correct. Now let's look at this graph. Suppose that, let's ignore this example. Suppose that look at this triangle. What is this triangle? This is a right triangle. right? Because it's on the 45-degree line. Now, if this is 1, then how much is this? This is the slope of the aggregate expenditure function, right? Let's call it B. Now, if this is 1, this is B, and this is 1, then how much is this? The whole thing is 1, and this part is B, therefore this part is 1 minus B, right? Okay, now here, how much is the increase in autonomous expenditure? The answer is 1 minus B, right? How much is the total increase in equilibrium income? The answer is from here to here, which we defined as 1. So when your autonomous expenditure increases by 1 minus B, the equilibrium income increases by 1. That is your multiplier. Did you see that? And what is B? B is the slope of the aggregate expenditure function. I just proved this. So multiplier is 1 over 1 minus the slope of the aggregate expenditure function. Now let's look at these two examples. This one, the slope of the aggregate expenditure function is 0.75. This one, the slope of the aggregate expenditure function is 0.5. That is, this country has a steeper aggregate expenditure function. This country has a flatter aggregate expenditure function. That is, in this country, the aggregate expenditure function has a bigger slope than the aggregate expenditure function in this country. The results, the multiplier of this country is 4. That is, if I increase the autonomous government expenditure by 1, my equilibrium expenditure is going to increase by 4 in this country. In this country, the multiplier is 2. That is, if this country increases the government expenditure by exactly the same, 1, then it will only increase equilibrium income, equilibrium expenditure by 1, by 2, because the multiplier is smaller. Let me ask you a question. So if, let's ignore imports. So all the slopes from the aggregate expenditure function is from the consumption function. And what is the slope of the consumption function? Marginal propensity to consume, right? So which one of these two is United States? And which one of these two is Japan? The answer is, this one is Japan, this one is the United States. Why? Because the United States has a higher marginal propensity to consume, right? So if we ignore imports, then marginal propensity to consume is higher in the United States. If all the slope of aggregate expenditure function is from the slope of the consumption function, which is marginal propensity to consume, then the United States aggregate expenditure is going to have a higher slope. That is, if both governments try to stimulate the economy and increase the autonomous government expenditure by 1, in the United States, the effect will be bigger. We can increase the equilibrium income, equilibrium expenditure by 4, but Japan can only increase it by 2. Okay, And that's exactly what I just said. If we ignore imports, only consumption will depend on income. Therefore, the slope of aggregate expenditure function is equal to the slope of the consumption function, that is MPC. Then the multiplier is 1 over 1 minus the slope of the aggregate expenditure function, which is MPC. That is, if we don't have imports. But in the real world, we do have imports. And we ignore income tax in the past few slides, right? But in the real world, we do have income tax. We do have imports. We ignore these two because it's easier for us to do the analysis. Now, if we add income tax and imports back into the model, what will happen? Well, the answer is both income tax and import will reduce the size of the multiplier. Why? Just use your intuition. First, income tax. Remember, when income increases, right-hand side, income increases, expenditure increases, right? And in the second round, income increases. But if the government takes some of the income, income will increase by less than the case where there's no income tax. Therefore, when autonomous expenditure increases by this much, the second round and the third round, fourth round, the increase in income here will be smaller than the case that has no income taxes. Therefore, the total increase will be smaller. So that reduces the size of the multiplier. The second one, imports. Remember, the induced expenditure is MPC times income minus MPM times income. So when we have imports, when income increases, the induced expenditure will increase by a less amount than the case that we don't have imports. So again, imports will reduce the size of the multiplier. Okay, so far in chapter 11, we have drawn the aggregate expenditure function. Aggregate expenditure is a function of income. And aggregate expenditure looks like this. If we draw the 45-degree line, this is our equilibrium income. But remember, what was our purpose? Our purpose was to draw the aggregate demand curve. Now, you cannot draw aggregate demand curve on this diagram because the aggregate demand curve should be in a demand-supply diagram. The variable on the x-axis is real GDP or income, or simply call it Y, aggregate income. And the variable on the y-axis is P, price. So we want to draw the aggregate demand curve. And remember I said aggregate expenditure function can help us to find the quantity demanded under a specific price. That is, this graph should give us a dot. How is that? Now let's go back to the to the original point in chapter 11. At the beginning of chapter 11, we say we fix a price level and then do the analysis all based on this price level. That is why we don't talk about real or nominal. Alright, so under this price level, we have this aggregate expenditure function. And the result is, this is the equilibrium income. And because you have the same x-axis, you can draw this income right here, and this is also equal to y1. Then we get a dot. Why? Because at a given price level P1, we have this aggregate expenditure function. And the resulting equilibrium income is y1. Therefore, under this price P1, the equilibrium income is y1. Therefore, this is our quantity demanded pair P1 and y1. That's how we get one dot on the aggregate demand curve. Let me do it again. Using the example in the textbook. Originally, we have this AE0. And then we have this equilibrium income 13. Therefore, when price level is fixed at 110, we have this aggregate expenditure function, and that gives an equilibrium income of 13. Therefore, we have this dot B. Now, suppose that price level increases from 110 to 130. When price level increases, what happened to the aggregate expenditure function? Remember, aggregate expenditure function is C plus I plus G plus X minus M. And we ignore this real in chapter 11. What is real aggregate expenditure? Remember the definition of real in macroeconomics? Real is nominal divided by aggregate expenditure function. Divided by price level, sorry. So real is nominal divided by price level. So real aggregate expenditure function is nominal aggregate expenditure divided by price level. Now, if the price level increases, the only event here is a rise in the price level from 110 to 130. Nothing about CIGXM. Therefore, aggregate expenditure doesn't change. So when the denominator increases, real aggregate expenditure decreases. Therefore, real aggregate expenditure function shifts down. Therefore, we have a new equilibrium A and the new equilibrium income 12. Therefore, when price goes up from 110 to 130, the new equilibrium goes from 13 to 12. Equilibrium quantity goes from 13 to 12. Then we get another dot. And that's a movement along the aggregate demand curve. Let me do it again. Originally, we are at A0, AE0. That is, when price is 110, we have AE0. We got equilibrium quantity 13. So we get one dot. When price level increases, real aggregate expenditure, which is nominal aggregate expenditure divided by price level, price level increases, real aggregate expenditure decreases. Therefore, aggregate expenditure function shifts down. We got a new equilibrium, 12. Therefore, when price is 130, we get another dot. That's exactly what happened. So, it's a movement when price goes up from 110 to 130. It's a movement from B to A along the aggregate demand function. On the other hand, if price goes down from 110 to 90, what happened? Price level goes down. Real aggregate expenditure is nominal aggregate expenditure divided by price level. When price goes down, denominator goes down, the whole thing goes up. Therefore, aggregate expenditure function shift up to AE2 when price is 90. Therefore, we got a new equilibrium income C, equilibrium income 14. So when price level is 90, we got equilibrium income 14. We got another dot, and it's a movement along the aggregate demand curve. It's a movement from B to C. Therefore, a change in the price level causes a movement along the aggregate demand curve. Sounds familiar? Yes, because that's exactly how we draw the aggregate demand curve. We change the price level, get a new aggregate expenditure function, get a new equilibrium income, and connect the dots. We draw the aggregate demand function. Therefore, when you change the price level, it only causes a movement along the aggregate demand curve because price level is the variable on the y-axis in the aggregate demand, aggregate supply diagram. Let me emphasize this again. On the aggregate demand, aggregate supply diagram, the variable on the y-axis is the price level. The variable on the x-axis is income. In the aggregate expenditure diagram, the variable on the y-axis is aggregate expenditure. The variable on the x-axis is income. So what causes a movement along the aggregate demand curve? One thing. That is, the change in price level, the change in the variable on the y-axis. So what causes a movement? Answer? Anything else. Anything else. Anything else that changes aggregate demanders' behavior. What is aggregate demanders' behavior? The answer is aggregate expenditure, because demanders have expenditure. aggregate expenditure is the behavior of the demanders. Therefore, other than the change in the price level, anything that changes aggregate expenditure will shift the aggregate demand curve. What is aggregate expenditure? What is aggregate expenditure? CIGXM. Therefore, anything changes consumption, investment, government expenditure, exports, and imports will shift aggregate demand curve. How? This is the case. Remember, aggregate expenditure function is C plus I plus G plus X minus M. Say, for example, investment increases. Okay? Originally, the equilibrium is at 8. So we have this aggregate demand curve when price level is 110. Now, if firms increases investment, therefore, autonomous expenditure increases. Did I change the price? No, I didn't change the price. I didn't change the price. Price is still 110. The event is autonomous investment increases. The result, we get a new equilibrium, income, 15. Therefore, when price level is 110, if firms increases autonomous investment, equilibrium income goes from 13 to 15. Therefore, when price is 110, because of the increase in investment, you get another dot on the original, on the right hand side of the original aggregate demand curve. Therefore, demand curve shift to the right. Demand curve shift to the right. That is chapter 11.